It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my wonderful co-host, Andy Grabner. And I was going to say something disparaging about him, but what I will say is, Andy, this is not our official 10-year episode, but to give listeners and our guests some clout, by the time we're recording this episode, we have been recording at least for 10 years now.
Wow.
Right? So
10 years.
Very impressive.
10 years. So
10 years.
Yes. And I believe, check this out, what I'm going to do here. I believe, there's been a lot of amazing topics and data, ideas we've discussed on these. We've had a lot of great guests, and we love our audience. And all this has connected us with all different kinds of ideas and people throughout time. So, and it's given a lot of context to our lives and the technology that we all love and share. Now, that was a really poor attempt. I was busting your chops, Andy, that after 10 years, you still don't know what you're doing with audio. And after 10 years, I still can't do a segue. So I'm going to hand it over to you. But that was my attempt, everybody. That was my piss poor attempt. Andy,
well,
do your magic.
It's almost as poor as my attempt to come up with good audio quality. And I'm extremely sorry that today I won't have the audio quality that people deserve. But I think what people deserve is a good conversation. It's a good conversation based on a wide variety of data inputs that we now just somehow need to gather and through a standard make it easier consumable. Maybe that's a segue. Not really the best, but
better than mine.
Today it's just not neither of our days. So the only hope that we actually have is that our guest today, who is actually a repeat guest on our show, will tell us more about what is this whole thing about MCPs, the Model Context Protocol. And Dana, before I let you speak, you brought this topic to me at Perform. This was first week of February this year, and I thought, MCP, never heard about it. A day later, I opened up my LinkedIn, and it felt like it was everywhere. And either this is just really proof that somebody's listening in, and then they are prioritizing certain topics in my feed, or you were really just at the pulse of time, and then it really took off. Maybe you, with whatever you did that day, you just sparked something. But Dana, thank you so much for being back at the show. We want to learn from you today about MCPs. What is it? And also, what does it have to do with engineering efficiency? And to get it kicked off, maybe you introduce yourself now.
Absolutely. Well, thank you for that introduction. And before I even get into that, here's to hoping that your 11th year of recording, you finally get good segues and good audio recording going. And congrats on the 10-year milestone. That's phenomenal. Thank you for having me back. I'm Dana Harrison. I am a staff site reliability engineer at Telus, which is one of Canada's largest telecommunications companies. We do home solutions, internet, home phone, mobile phone, TV, all of that fun jazz. And we have, led by some incredible people, been enormously stepping into the AI space. There was a big press release we did a couple of weeks ago, I think at this point, about how Telus is actually going to be standing up Canada's first sovereign AI data center in a partnership with NVIDIA, which is amazing news. So we are definitely, I think, way further into this space than a lot of other people, especially in this part of our industry, but I think just generally. And yeah, Andy, as you said, MCPs, I first learned about these at the end of January. I think Anthropic released them in November, something like that. And we've just been going absolutely gangbusters with them so far.
Yeah, and I just came back from KubeCon London last week, And there was obviously a lot of talk around AI, around LLMs, new protocols to better and more efficiently route the traffic to LLM workloads, because LLM workloads are different to our regular request response based workloads that we know from our classical applications. I think at the time of the recording, Google Next is happening right now in Vegas. There's a lot of talk around agentic AIs and building agents. They just introduced an agent-to-agent protocol. So there's a lot of things going on. But really, for those people maybe to get started that have not heard about MCPs yet, and this whole topic on making the AIs easier available, can you, Dana? What have you learned? Even though for you it's also a rather, let's say, young journey, can you quickly explain what MCPs are all about?
I can do my absolute best. So I really like the way Anthropic themselves have described MCPs, which is USB-C for AI. So that, the reversible plug that connects to everything. That's essentially it. There's nothing really that intelligent about an MCP. An MCP is just the interface for an LLM to be able to interact with external resources. So let's say I've also heard it described as something like JSON over HTTP, and that's really it in its most basic form. You are enabling an interface for an LLM to interact with a tool by parsing out the data that it's getting from it. So you can, using Klein, for example, this is an Anthropic thing. So you can use Claude Desktop, you can use Klein with any of the Claude models, but it's starting to become a very, very widely adopted standard, which is fantastic, and I really love to see. But yeah, that's really it. There's not too much magic to it. It's just a way for an LLM to interact with external systems and data, and then start to interpret that.
The concept is that I think some of the stuff that I've read up to, right? It's one example I just saw in a video, and folks, there's so many videos out there that explain MCPs. One was, hey, if I want to ask a question, says, what is the chatter in our organization right now, whether on Slack and in emails about a particular topic? And then the idea with MCPs are that you can then build MCP servers that can actually then, let's say, reach out to Slack, reach out to email, and then pull back the data for a particular topic, and then have the LLM on top or in front of it and say, hey, how can I now, I guess, make this easier human consumable?
Yeah, so in that example, that's a great example. I love it. You could build an MCP server or two separate MCP servers if you wanted. You could build one for Slack. You could build one for, Google Chat or whatever you're using, and say, in the MCP, that is where you're building out the context of how do I interact with this tool. So like what REST, what gRPC or REST calls am I making? What database queries? How am I actually pulling the data out of this? And then you expose those tools to the LLM. So you can say, in Claude, in Klein, you can say, hey, go get me the chatter on this particular topic. You could provide some directive around that in your Klein rules, in your, whatever, wherever you're making those configurations, and say, if you're getting a question like this, go use these tools. Now, for the most part, it'll figure itself out. But if you're like me and have about 24 MCPs installed, it does start to try and conflate things a little bit. But you can provide it that directive and say, if I'm getting a question to the effect of, what is the chatter on this topic? Go use these tools. And it will then build out the JSON as per your MCP definition. Go make those calls. The MCP makes those calls. The LLM is just essentially building out the JSON to make the calls for you. Go get the response back, interpret it, and then put that in human readable format for me. We have, if you go take a look at the public MCP registries, it is a space that has absolutely exploded over the past couple of months. We at Telus have built out dozens of MCPs at this point, especially with the power of not, outside of MCPs, just using sort of regular Klein AI magic or Roo code AI magic at this point. It is trivially easy to build your own MCP to interact with whatever service you want.
Yeah.
So Andy,
Brian,
the good news there is that you can use this then to go onto Slack and say who's trash talking me,
Who's to say I haven't already done that? No, I haven't.
Yeah.
If any Telus listeners, I absolutely have not done that and do not have the ability or will to do so.
Yeah. My other dumb
Well,
joke is there going to be a micro MCP then? If it's the USB
Oh, no.
connectors. Yeah.
God help us if they ever
had to get
introduce
that
like
in there.
micro USB-C. Just like
Yeah.
the tiniest. It's just a barrel jack.
Yeah.
But
Andy, you were
I
gonna
guess
say
as you said, right? I mean, it's in the end, MCPs is not magic. It's just a standard that was specified or donated by Anthropic and said, hey, instead of us and other vendors building all these point-to-point integrations with Slack, with MS Teams, with your backend database, with whatever 50,000 different systems, we are proposing an open standard so that we can have LLMs or our AIs connect to any type of backend data source. And I think it's not only data source, it's also actions. What I've seen is some explanation, and correct me if I'm wrong, that an MCP server can not only query data, but you can also obviously do certain things where you can say as a developer, I want somebody to send out a message for me. Or like a summary, give me a summary and then send out a message, and then the MCP server can also then execute an action, if I'm correct about that.
Yeah, that's really all based on the constraints of how you've built out an MCP server, and that's one of the sort of great the great benefits of this model is that it is only constrained to how far you build out the MCP server. So if you want the MCP server to be sort of read-only, you're interacting with these remote resources in a very safe way. Let's say you're working with Dynatrace and you want to build an MCP server against your observability platform, but you don't want to expose all like 30,000 API methods to the LLM. You could build out just a few and then say, these are what you get access to through the MCP. And then it's something that is predictable and repeatable. And there's no reason why you couldn't then also say, the LLM is doing the brunt of the work in trying to figure out sort of how to format this query, et cetera, and then sending it to the MCP. So there's no reason you shouldn't be able to say, I want to send out a message, make it look like this, and then using the tool of exposed to it from the MCP, it figures that out. And, if you have a method available, if you have a tool available in the MCP that has the ability to post a message out to Slack, then it will do that for you.
Mm-hmm.
So you just said something that blew my mind here. When talking about just in context of the Dynatrace APIs, but I guess this goes for anything, which is what you were saying all along, the two of you with this example. I remember there was a time when I was doing a lot of work against the Dynatrace API years ago, and I'd have to read through the documentation, figure out all the fields, and there's a bit. So now this is just straight up AI kind of stuff, but with this protocol, obviously it makes it easier, where I can have the protocol connect my LLM, it can learn all this stuff for it, and then instead of me trying to figure out the API, I can just type into or speak into my thing and say, fetch me this from the API. Or I might not even have to tell it from which API. Fetch me this from the tool.
It's that easy.
So that's why you need the MCP.
Like
So that's why you need the MCP, because if it's not standard, that's going to be a real pain in the butt for...
It becomes a huge pain.
Yeah.
Even thinking we've been on an AI journey for a while here, and thinking back to maybe 8-10 months ago, I was trying to connect it to Google Drive, and it was a huge pain, and vectorizing things, and that is just all gone now. The ability for us to interact with remote resources has absolutely exploded since the dawn of MCPs.
Yeah, it's amazing how quickly this came up too. A lot of times when people start saying, hey, we should standardize on something, that's years down the road. We're nowhere near that far into, acceptable or widely adopted AI, and we've already got this going. So that's really cool in its own way, I guess.
I think Anthropic really scratched an itch. This is they found that a lot of people were trying to do something like this and figured out the right way to standardize it. Because you're right, it feels like the new selling point for anything is this has an MCP server that you can install. It just is. It's the new sort of shovelware. We'll throw an MCP into it, and then it suddenly is groundbreaking. But it really has been a huge, huge enabler for us.
Now, Dana, in the last meeting we had, so I had you on our Dynatrace Guild, and you and your colleague, you showed where in Visual Studio, as an engineer, I could say, describe my service or give me some hints on what are the hotspots of a particular service I'm responsible for. And the way I remember it, your setup basically then said, well, we have traces and metrics in Dynatrace. So we're pulling that data in from that service, metrics, traces, but you have your logs, I think, somewhere else. So it also then goes off to that log system. And then the LLM takes all this data and then says, hey, it seems that, there's certain metrics that are, there's a response time hotspot, there's a failure hotspot, there's some transactions that look strange, and there's also some logs that look suspicious. And then the LLM brought a nice summary of everything that I need to know as an engineer. But as an engineer, I don't care in the end where the data comes from. I just phrase the question, show me the 5 hotspots in my service, and then the through MCPs, the relevant data gets pulled in, and then I guess gets then perfectly formatted, or like whatever the LLM is then doing to portray it and provide it in a way for the engineers so that they can actually make sense of it without them having to go to every single tool and trying to find this information themselves.
That's a really, I'm glad you brought up this example, because funny enough, we just recorded a demo internally the other day that this reminds me I should send to you, and I'll talk through. But yeah, in the Automation Guild, we walked through sort of a small subset of this. And until now on the podcast, we've been really talking about like, oh, you can go query or interact with like a single MCP or a single tool at once. But there is no reason with the right directives why you can't chain commands in between MCPs and have them continually sending output from one to another. So yeah, in your example, Andy, you're absolutely right. In one observability solution, we have our traces and metrics, but in another, we have our logs, and there are lots of reasons for that. But now our developers don't need to care with the fact that we have trace context injection into our logs. So our logs have trace IDs. You can correlate those two things anyway. It is trivially easy for us to say, given a particular service, go investigate how this service is doing. Pull back all the traces I need that are, maybe anomalous, pull back all the signals I need. From those traces, pull back the affected log entries and summarize it for me. And that, I would say, is even a small use case for what we're doing now. Based on what we demoed just 2 weeks ago, we've managed to grow it out even more. We just built out a demo internally that we're hoping to get our developers on board with, where let's say it's 3 a.m. You get a PagerDuty alert. Nobody ever wants a PagerDuty alert. Shout out to that incredible team, but nobody wants a PagerDuty alert at 3 a.m. You get one. You take that PagerDuty alert number and you pop into your Visual Studio Code. You've got your repo open. You've got client open. You've got all your LLMs set up, and you say, "Tell me about this problem." Give it the problem number. It pulls it in. It pulls in all the alert details that led to that problem or that alert in PagerDuty. So let's say you're going Dynatrace to PagerDuty. It then goes into Dynatrace, pulls the affected entities from that problem card in Dynatrace. It pulls root cause. It starts pulling back all of the signals on that. And then based on that, and at this point, you could have interacted with 3 different MCPs all at once automatically. You could say you've gone to MCP PagerDuty and Dynatrace into your logs one. And then based on the output of all that, recommend fixes to my code. Now you're outside of MCPs. You're just into regular Klein. And I love that Klein is just sort of, it's just regular Klein. It's just AI now. It's not even MCPs. And from that, make recommendations to my code. Provide further directive to say, once you've made fixes to my code, submit a Jira ticket. Go submit a GitHub PR. And now from PagerDuty to pull request, you've done something in 10 minutes. The ability to chain in between these tools and remove developer context switching and really enable them to see the data where they are in their IDE without having to have that huge understanding of what is my service named in Dynatrace and where are my logs and I have to go search for this. And it just does it all for you now.
Yeah, I think that's an awesome use case, because also the way I understand it, that means in your case, Klein, it keeps also the conversational state, right? So I guess as an engineer, hey, tell me everything I need to know about this particular problem. And then it reaches out to various tools, maybe also to your internal communication channels, because maybe somebody has already had a conversation with external people on a ticketing system. So bring me everything, and then recommend a potential fix for this particular problem, and then show me in my source code where I can fix it, even do it. So that means it's really like you are the one person that is then using all of these assistants that you have to really get your work done in a much more efficient way. And those assistants are driven by data that comes from different tools. But now with MCPs, coming back to this, these tools are now basically proxied through a common layer and a common standardized interface. And that means everybody that supports MCPs and whoever, like both on the MCP server side, when you build an integration with an external tool, and also the ones that are then consuming this data through the MCPs, this will be a lot of time saved in building all these point-to-point integrations. This also almost reminds me, and I know I haven't used that word in a while, Brian, but in Captain, we actually, finally, Captain, ta-da!
He said the thing.
I said the thing. So with Captain, we standardized the way we bring in observability metrics back into Kubernetes to make automated decisions on deployments. And we basically standardized the metrics provider so that any type of tool that you have, whether it's Dynatrace, Datadog, New Relic, whatever you have, you can bring this data into Kubernetes and then use it for automated validations or even for your auto-scaling. So we standardized so that you only need to build one integration and not many point-to-point integrations. That was kind of the idea. Yeah. Cool. So MCPs, model, context, protocol.
Exactly.
I know you said Anthropic with Claude, right? Claude is their offering.
Yeah, that's primarily who we're using it through, but I think a whole bunch of it's very, very new in terms of like other people starting to onboard into it. I don't even have the latest information on who all has started accepting MCPs as a standard. Mm-hmm. But while Anthropic introduced it, it has really, really taken off across multiple like model providers and things like that. Mm-hmm. Which is great. It's that plumbing that we need to make all of our lives easier. I mentioned this. We actually legitimately recorded a demo the other day where we introduced purposeful bugs into our demo application for the purpose of the demo, but we were going slowly so that we could show for the demo. But we had in a 17-minute video, like got a problem notification and had a fix deployed to prod in 17 minutes, and that was moving slowly. No. And with minimal interaction from us, like literally just go to these, provide some directive on here's all the tools I want you to hit, and you only need to set that up once, and then off you go, and it just deployed it itself. It's a just wildly powerful tool, and this is like, I feel like we're using the old version of MCPs now, as old as something from November can be. Mm-hmm. Things move quickly in this space. We all know that. I feel like I take a weekend and then I come back on Monday and I'm like, what new thing has been introduced that has completely invalidated the last 15 years of my career? Now with remote MCPs, there is even more possibility to interact with these systems. Like, have you either of you read too much into remote MCPs, or what's been the work been happening there?
No, we're both shaking our heads for the people that cannot see us in the podcast.
This is a shake your head sound.
Yeah, I was about to say, if you could really shake it a lot more animated, then we will be able to hear it as all of the listeners. Remote MCP is not something I've played with too much at this point, but sort of. The great thing about MCPs is especially like in Telus, we have an internal package registry of MCPs. So it's very easy for somebody to say, all right, do an npx install of this MCP. Everything comes with a README because we're using Klein to develop all of our READMEs. And from there, plug in, whatever resource you're interacting with, plug in your API keys for that resource. So let's say I'm interacting with Dynatrace, give it an API key, and you're off to the races. But that isn't necessarily, for non-developers, the friendliest way of interacting with these systems. So I don't necessarily want to say, hey, for example, I recently built an MCP. We have 3 different change management systems at Telus. It is a long story. I built an MCP that says, go out to each of these change management systems, pull all of the changes in whatever time frame I specify in the LLM, grab those back and do an analysis on it. It's not super complex, but it requires API credentials that were difficult for me to acquire through like the usual methods and stuff. And rightfully so. They don't want everybody like totally hammering our change management solution and overloading it. I get it. There are great reasons for those to be tightly controlled. But what that then means is anybody who wants to install that MCP then has to go get their own API credentials, because you don't want to like bundle that necessarily, right? You don't want to put that in the package and be like, here, everybody use the same API credentials. There are security concerns about things like that. We don't do that here. But it does make it more difficult for people to get in on the ground level if they don't have sort of that base level of knowledge necessarily. And again, you can add things to a README, like with our Dynatrace MCP, our PagerDuty one. Those are easy. It's easy to make an API key and go, and we don't really care about sort of the usage and things like that. Go for it. Easy to scope. We can audit that. Legacy solutions, a little harder. Where remote MCPs come in is this is something you can build and deploy, and it can just be coded with all of the API keys to remote systems and stuff. And to all listeners, I will apologize now if you hear bumping or biting sounds. My cat just woke up, and she will try and go for this microphone. But with a remote MCP, you can build this, you can deploy it somewhere, you can point Klein to it just like everything else, or Claude Desktop, or whatever, your preferred MCP interaction tool. Cursor, I think, will do it too. And then there's authentication you can build on top of remote MCPs so that you're not just completely hammering them. But then the centralization of how to interact with that tool is all done through the remote MCP. Makes things a little bit more user-friendly, makes things easier, if you want to expose the remote MCP to a web page, for instance, and then you're starting to interact with these MCPs through web pages, and having it do that interpretation. It's a very, very cool way of interacting with these things, which then also introduces a whole bunch of like wild magic around server sent events that I've just been starting to read into, like SSEs, which is a streaming protocol for servers to be able to send events back to the client. In this case, it's one way, so that they can continue with request response. It is a whole new world.
For me, this sounds now. There's a couple of things that I wonder at enterprise scale. If you have these MCP servers and they're talking to multiple critical systems in the backend, and if I am Andy in one team and Dana, you are in a different team, and then Brian is in the third team, and we're all against the same MCP server, how would you handle the privilege system? Like maybe I'm not allowed to see certain things. How would this, if the MCP server is set up with a certain token to a backend system, how do you make sure that I only get to see the data that I'm supposed to see? So that means, right? I mean, that's an interesting.
That's a great question. Again, we haven't really played too much with. You're talking about like remote MCPs in this case, I suppose.
Well, not only remote, but if you're also in your organization, your team, well, I guess if you do this, if MCPs by default are more like personalized setups, and then you are setting it up for you or your team with your team credentials, that makes it easier, right? You need to get those tokens for your team. But if you start sharing these things, how do you propagate your credentials, your identity?
Yeah, so we'll use sort of both examples here. So if you're using a local MCP, this could be something that is a tool that is shared, or a tool set that is shared within your organization. But ultimately, the ability for that MCP to interact with a remote system is scoped to, one, how the MCP was built out, and two, how your API token on your local is scoped. So if you only have access to view certain things, the MCP is only going to have access to view those things. That is, I would say, a little bit easier to control. Once you get into deploying remote MCPs, as far as I know, do support OAuth. So you can scope things further into that and say, if it's this user, then this is the things they get scoped to. You could have a list of API keys that are stored server side, and each of them has a different set of scopes that an OAuth user would get access to. Would just be one example of how to control things like that.
But in general, because you also mentioned earlier performance, stability, if we are opening up all of these different tools now to natural language interaction, chances are that many more people will now use data and need data from systems that they normally never logged in. So these MCP servers need to be engineered also in a way that they're not killing the backend API, that they're building some caching, that they are, they need to be resilient, I guess. I'm not sure. How do you run an MCP server? Is this just a container that you deploy anywhere, or how does it work?
Not even. It's essentially just a file. It's like we're building ours out in like TypeScript. If you're building them locally, so if like 100 developers have an MCP installed, it's literally just like a TypeScript build file, and you're saying this is the way in which you interact with this tool. It's not even so complex as something you have to run on a given port. All you're saying is this MCP server is this file, essentially. Like that's really as easy as it is.
And then, but who runs this file, and who runs, like, where does the logic then run?
It's all run locally. So with traditional MCPs, it's all run locally. But you're right, there are considerations to the builders and maintainers of a particular MCP to then make sure that, depending on how that's getting used or will be getting used by the people in your organization, that it is being used in a responsible way. So, if you're building out an MCP that's hitting a legacy system, but you've got 100 users who are now connecting to this legacy system, I mean, theoretically, you could build out the MCP to then like target a remote cache, and you could probably do a whole bunch of magic like that. But if, let's say, you're running purely locally, then yeah, you'd want to make sure you're building out that API logic in a safe way with things like circuit breakers in place. So you're not saying like, hey, this API is down, go slam it 100 more times this second so that I get a prioritized response when it finally comes back online. You do need to consider those things. It's a very, very interesting way of, as you said, these users may not normally be logging into these systems because maybe they find them too challenging. Maybe they haven't necessarily needed the data in a way that has been easily presented to them before. And this makes it now much easier for them to access that. In our Dynatrace MCP internally to Telus, we actually built out so you can validate and run DQL queries. For those who are using DQL, that if you're not putting proper constraints in place, that can get expensive if you're running enormous queries, repeated, etc. So we built logic into our queries to say, validate this, provide the user with an answer on like, this is how much this is going to cost to run, heads up. Make sure you're building out DQL in an efficient way, limiting things. In our example we built out the other day, we're only pulling back like the top 15 or 20 traces. Like we only need to examine, just a little subset of data. So we're trying to build those constraints or those, not constraints, but controls and efficiencies in at the MCP level to say, you want to interact with this remote system in a sustainable way. Here's how you can do it.
It also
go on, Andy. Finish your thought there.
Yeah, it just reminds me, last thought on this. If you remember back in the days, and I know they're still around, the mainframes, and they were only hit when you went to a bank and you went to the teller, right? They were opening up the terminals. And then they were the ones that were hitting the mainframe. And then the websites came, online banking, and then mobile banking came. And I remember stories when the first mobile banking apps were basically, obviously, every time I opened up my mobile banking app, it was making a call to the backend mainframe. And that became hugely expensive. And nobody thought in the beginning that instead of 10 people working in the bank, now you have 10,000 end users potentially hitting the mainframe, and not just once a week when they go to the bank, but once a day, because now everybody wants to see their bank account statements or like their current amount on the account. And I think this is right. This could come to a similar. I think we may end up in a similar situation where if we make it now very easy and convenient to access certain data without even knowing by the end user where this data comes from and how expensive it is, you got to be very careful with what you build.
Absolutely, you do. And I was trying to remember. I used to work in an org that was big into mainframe, and we're in the insurance industry, so still big there, still big in finance and insurance. For the folks who didn't know, mainframe's definitely still alive and kicking. And I could not remember the name of like how they discern like compute units within an LPAR in an IBM ZOS mainframe. But yeah, you're absolutely right. We now have to be more considerate consumers of these data, to which we now have, depending on how the MCP is built, essentially unfettered access.
Yeah, and Andy, I'll one up you on that, because you led into another aspect of where Dana, earlier in that last bit, you said you had mentioned the word cache at some point, and that immediately made me think about, I don't even know it was in the context of what you're saying. I was like, do we need caching layers for some of this data? Right, because if you're going in and 20 people are requesting the same data because the MCPs make it so easy, do we want to really query that data set 20 times within 5 minutes, or are we doing a caching layer? And I know I'm saying kind of like query, but is the way this stuff being constructed, are we now introducing N+1 problems? Like, with the LLM that's going to be developing this, we suddenly start. First, we have this awesome thing where AI is doing all this amazing stuff, but then as it becomes used a lot more, we go back introducing potentially many of the same performance patterns or anti-patterns that we've seen throughout the years into this new model, which is, I know, one of Andy and I's favorite topics, because it always comes back, everything that's old is new again. And just even, you were talking about the different kinds of loads. So if 20 people have this local file running on it, obviously on their machine, you don't have to worry about it, but is that going to overload the API? If you have a remote MCP, how many people are using it at once? Is that machine that's even running on going to be able to stand up, right? Not, regardless of what kind of load it's going to put on the back end. And are all these tool developers, are they ready for their APIs to be being hit that much? Okay, what optimizations are they going to have to start making, right? This thing is just suddenly snowballing in like the last 10 minutes of our conversation, and my head's exploding with this,
Absolutely. It's a great point. I'm glad you brought it up. I know we sort of talked about caching earlier. I hope that if you have a solution in place where, this server could potentially be, this remote resource could potentially be getting hit 20 times in a row with the same query, that server has some caching or controls built in to say like, hey, I got this more than a couple of times. I'm going to go put this into an in-memory cache like a Firestore or something. Yeah. So I would hope that solution is more server-side than the client having to worry about it. But you made a great point. Especially as we're building out these MCPs using AI, these AIs are only as good as the patterns on which they were trained. So if we have years and years and years of anti-patterns on like, hey, I'm not going to reuse database connections, I'm not going to use connection pooling, I'm not going to use circuit breakers, and that's what these things have been trained on. As you're building these out, that is a consideration you absolutely have to make when you are trying to be a good consumer of the data for your MCPs.
Yeah, absolutely. And it's not like it's the MCP's fault that this is happening, but it's the MCP that's allowing the ramp up to all this to accelerate so fast. And I think a lot of people are going to probably be caught off guard because they're like, oh, well, it's going to be well. Oh, wait, we're here. As you're seeing, you've been saying this all along. It's like every single day almost some things are changing and getting more advanced. So, the performance considerations can't be put off, right? It's, it's very, very interesting. Very interesting problems.
Absolutely. That's how I feel every morning, Brian. It's like I wake up and it's just, some new thing has been introduced, and like now I have to go learn this. And it is an exciting time to be a software developer. I have a colleague who was talking about this, like traditionally, and not that I would call myself a software dev. I'm an SRE, but I have a dev background. Mm-hmm. I have a colleague, Ahmed, who made this great point about, for years, software developers have been the ones disrupting other industries. And now suddenly, here comes AI and these tools to disrupt our industry. it is a paradigm shift that the likes of which I don't think we've ever seen in this profession before.
Yeah.
And huge shout out to Ahmed, because I think that was a really, really well made point. So it's an exciting time, but it is like there's a lot to keep up with. Yeah.
Yeah. It's almost in a way the robotization of factories, where now the factory workers become, robot and computer maintainers as opposed to the actual factory line workers. But if you have one of those advanced factories, you're still employing people, but with a different skill set than if they were actually on the assembly line, right?
I'd like to propose that I get a formal job change title. I am now a prompt reliability engineer. No longer an SRE. I am now a PRE.
You heard it here first.
Yeah. No, it's fascinating. Do you know, because we're getting close to the end, do you know if there's any built-in observability into those MCP servers and how the client is interacting with it? Because I want to know how expensive is not only expensive, but what's actually happening when an engineer executes a certain prompt, like what you said earlier, explain or investigate or describe a certain code base, and then it goes off to multiple different tools and gets all the data. Do we know, is there any observability?
Not that I've seen, but that would be relatively trivial to build in. I mean, LLM observability, obviously huge industry. I know Dynatrace is getting way into that. When you're working with things locally, like you just have your MCP definition in a TypeScript file, you could absolutely say, as you're interacting with these resources, fire off an event saying, this is how I interacted with this. You could also do it server side. So given a set of particular keys that are the ones that are interacting with MCPs, go push your events, go show how these things are responding. So I think there are lots of points at which you could build in that observability, but it's not really a consideration that I've seen made yet. Now it's very, very possible, as with many things in the AI world right now. I am just super out of the loop on that. But I think that's a really cool point, and I would love to see that taken a little bit further.
Yeah. Well, as this is still a new topic, but it seems like there's a lot of stuff already happened just in the last couple of months, and I'm sure there's more happening. Dana, it would be nice to follow your experience in that matter over the coming months, and especially with your bodybuilding. Maybe we'll invite you back in a couple of months and say, hey, what has happened in the time we spoke last? And I'm sure maybe the next cool thing is coming up, but who knows?
You know where to find me. I would love to come back and chat more.
Yeah. I think this is going to be a lot. Yeah. Just based on the speed of the things changing, I think this is going to be one of the more heavy topics. And again, it's like, oh, AI. But, as we're talking about this isn't necessarily about AI. This is about the runnings of AI, which I think is the more interesting side of it, right? Because everybody can talk about, oh, AI is doing this, and this. Like, oh, yeah, but how does it run? And that to me is the more fascinating part. And so if you're sick of AI, this isn't AI. This is how AI runs.
That is a fantastic distinction. I've seen so many posts on LinkedIn talking about, oh, MCPs are AI. They're not. They're just the plumbing for your AI to talk to things.
Exactly.
There's nothing wildly magical happening in the middle.
Yeah.
It's all the infrastructure is mundane. It's what runs on the infrastructure that's cool.
Exactly.
Like the first monorail. Cool. Yeah.
Brian, I'm sorry that I disappointed you in the beginning again with bad audio quality. I promise in the next 10 years of podcasting, I'll do an effort to always have a good microphone at hand. I'll do my best.
Now you're leaning down, talking close to the microphone, changing your audio quality. That's okay, because in that last bit of interaction there, I forgot to unmute. I'm recording directly to Cubase, and I forgot to unmute my mic, so I'm going to have suddenly switch to Zoom audio quality for that last bit, and then back to this. So I make the mistakes too. See, we're human. We're not AI, Eddie. We cannot be perfect, right? Nor can AI, I guess. But yeah. Anyway, it's been fantastic. I guess we need to wrap up here. We're getting to the end there. So why don't you do your typicals?
Yeah, no, as I said, Dana, thank you so much. It's always great to have people on the show that introduce us to something new. The goal that I had for this call, and I told you this in the beginning, I want to know more about MCPs than an hour ago. And I do. It's great. It's great to hear these use cases. I think that's important for people that listen to this, that wonder what is the real use case for it. You had a couple of great use cases that you also demoed, and I'm looking forward to the demo videos that you sent me. And I'm sure we will see you probably at one or the other conference in the future talking about this or other topics. And all the best, and keep us posted, because it's an exciting topic for everyone.
Will do. Thanks again for having me, folks. It was a pleasure chatting with both of you.
Yes, it's also a pleasure hearing that smooth voice of yours.
Oh, yeah.
It's funny, too, because I got to say, when I was first looking into this, I was like, boy, this sounds boring. MCPs, and I saw like the USB-C cord. I'm like, all right. But, it's not. It's about what MCP, the MCPs themselves. Yeah, there's some interesting things in what they do, but it's what they enable, right? Yep. And that's what my big takeaway from today is like, this is changing everything because of just the enablement factor. It's almost like, I guess, watching the dawn of HTTP, or something like that, where there's suddenly a standard of how everything can communicate, and that's going to blow everything up. Maybe both literally and figuratively. We'll have to see what the machines
Find
do.
out in your 11th year of podcasting if
Yes.
the world literally explodes.
Thank you. But yeah, thanks a lot. Look forward to the future episodes about this. And thank you so much for being a repeat guest.
Thank you.
The Repeat Club. All right. And thank you for all of our listeners. We'll give you the official 10-year thank you next time. But thanks if anyone's been with us this long, thank you. That's all I can say. And see you all next episode. Bye-bye.
Bye-bye.
Bye-bye.